Good morning, students. We are studying Block 3 Systems Analysis and Computer Languages, MPC08 Information Systems for Managers. Block 3 Systems Analysis and Computer Languages. Unit 11 Computer Programming and Languages. Programming languages form the cornerstone of interaction between humans and computers. You see, link between humans and computers. To solve any problem using a computer, instructions must be written in a specific, programming language. Forming a computer program, these programs serve as an interface bridging human intent and machine execution. Programming languages can be broadly classified into 3 categories: low-level language, assembly language, and high-level languages. So, students, programming languages form the cornerstone of interaction between humans and computers. To solve any problem using a computer, instructions must be written in a specific programming language. Forming a computer program, these programs serve as an interface bridging human intent and machine execution. Programming languages can be broadly classified into 3 categories: low-level language, assembly language, and high-level C language. Low-level language, machine language, comprised entirely of binary code, zeros and ones. This language is directly understood by the computer's hardware, but is exceedingly difficult for humans to learn, write, and debug. Assembly language, a step above machine language. It uses mnemonic, codes. While it simplifies programming to some extent, it remains highly machine dependent and requires expert knowledge. So, under machine language, it comprises entirely of binary codes, that is 0 and 1s. This language is directly understood by the computer's hardware, but is exceedingly difficult for humans to learn, write, and debug. Assembly language, a step above machine language. It uses mnemonic, codes. While it simplifies programming to some extent, it remains highly machine dependent and requires expert knowledge. High-level languages. These languages are user-friendly, employing English-like syntax and logical structures that are easier to learn and understand. Examples include C, C++, Java, Python, and VBNet. High-level languages are platform independent and are suitable for a wide range of applications. They enable developers to focus on solving problems rather than dealing with machine-specific details. So these languages are user-friendly, employing English-like syntax and logical structures that are easier to learn and understand. Examples include C, C++, Java, Python, and VBNet. High-level languages are, platform independent and are suitable for a wide range of applications. They enable developers to focus on solving problems rather than dealing with machine-specific details. Programming vocabulary. Every programming language has a specific vocabulary that defines its syntax. That is, syntax means rules, and semantics meaning. Understanding this with all browsers, ensuring universal accessibility. Microsoft Excel Excel is a powerful spreadsheet program that allows users to organize, analyze, and visualize data effectively. So about Microsoft Excel, Excel is a powerful spreadsheet program that allows users to organize, analyze, and visualize data effectively. Now, next is features of Microsoft Excel. First feature is cells, basic units of data entry found by intersecting rows and columns. Second feature is formulas and functions, perform calculations and automate tasks. Third is graphing tools, create bar charts, pie charts, and more for data visualization. Fourth one is formatting options, customize the appearance of data with fonts, colors, and alignment. Next is data security, protect workbooks with passwords to prevent unauthorized access. These are the features of Microsoft Excel: cells, formulas and functions, graphing tools, formatting options, data security. So under this unit, we have, studied. This unit provides a comprehensive introduction to programming languages, control structures, and tools like VBNet, Java, HTML, and Excel. It emphasizes the importance of programming in problem solving and explores features that makes each and uniquely suited for specific tasks. Mastery of these concepts equips learners to develop efficient, secure, and versatile software applications. So under this chapter, what we have studied, under Unit 11, Computer Programming and Languages. Programming languages form the cornerstone of interaction between humans and computers. To solve any problem using a computer, instructions must be written in a specific programming language, forming a computer program. These programs serve as an interface bridging human intent and machine execution. Programming languages can be broadly classified into three categories: low-level language, assembly language, and high-level language. Now, low-level language. Under low-level language, we studied machine language, assembly language. Machine language comprised entirely of binary codes, 0 and 1s. This language is directly understood by the computer's hardware, but is exceedingly difficult for humans to learn, write, and debug. Next is assembly language, a step above machine language. It uses mnemonic codes. While it simplifies programming to some extent, it remains highly machine dependent and requires expert knowledge. Then third one, we studied high level languages. These languages are user friendly, employing English like syntax and logical structures that are easier to learn and understand. Examples include C, C++, Java, Python, and VBNet. High-level languages are platform-independent and are suitable for a wide range of applications. They enable developers to focus on solving problems rather than dealing with machine-specific details. Next is programming vocabulary. Every programming language has a specific vocabulary that defines its rules and meaning. Understanding this vocabulary is crucial for writing effective programs. Key elements of programming vocabulary include keywords, reserved words like if, then, else, while, and repeat have predefined meanings and cannot be redefined by the programmer. These words form the foundation of programming logic. Next is identifiers. These are names given to program elements such as variables, functions, and subroutines. An identifier must begin with a letter and can include letters and digits. For example, in a program calculating factorials, fact might represent the factorial of a number, while n represents the input number. Next is variables. Variables are entities whose values can change during program execution. For instance, n and fact are variables in a factorial calculation program as their values update during execution. Next is constants. Constants are fixed values that do not change during program execution. Numeric constants like 10 and a string you see constant like hello are you see examples. Next is you see expressions. An expression combines variables, constants, and operators to produce a result. For instance, fact is equal to fact multiplied by n is an expression that updates the value of the factorial. Next is you see operators. You see there are arithmetic operators, relational, you see operators, logical operators. Now arithmetic operators plus addition, minus subtraction, then star multiplication, then division. Second one is relational. You see operators less than, more than, equal to, less than, equal to, equal to. Logical operators and or not. They are logical operators. Now control structures in programming. Control structures determine the flow of execution in a program. They can be categorized into branching, looping, and jump statements. Branching statements, these allow the program to make decisions based on conditions. Examples are if, then, else. Executes one block of code if a condition is true and another if it is false. Case statements used for selecting one of the several blocks of code based on a variable value. Looping statements, these enable repeated execution of a block of code. For loop, illiterates a known number of times, while loop executes as long as a condition is true. Do until loop means executes at least once and continues until a condition becomes true. Next is jump statements. Go to, break, continue. Go to transfers control to a labeled part of the program. Break exits a loop immediately. Continue skips the remaining code in the loop's current iteration and proceeds with the next. Next is VBNet. VBNet is a programming language developed by Microsoft, building on its predecessor, Visual Basic VB6. It is part of the .NET framework and supports object-oriented programming. Now, key features of VBNet: object-oriented, cross-platform compatibility, ease of learning, efficient execution. So, under object-oriented, supports encapsulation, inheritance, and polymorphism. Cross-platform compatibility, programs can run on Windows, Linux, and macOS. Ease of learning, derived from the simple basic language. It is beginner friendly. Efficient execution, VBNet ensures optimal memory and processing usage. Control systems in VBNet are if, then, if, else, and select case for branching. For, while, and do until for looping. Overview and features of Java. Java, developed by Sun Microsoft in 1991, is a high-level general-purpose language known for its platform independence. Its slogan, write once, run anywhere, in short we call it WORA, highlights its portability. Key features of Java. Number one is platform independence. Programs compiled into bytecode can run on any machine with a Java virtual machine. Object-oriented, every element in Java revolves around objects and classes. Security includes feature like bytecode verification to prevent unauthorized code execution. Multi-threading allows simultaneous execution of multiple tasks. Dynamic and extensible supports dynamic linking of new classes and methods. Next is structure of a Java program. documentation section, then package declaration, then import statements, then class definitions, then main method. Java data types, primitive, non-primitive. Primitive is, you see, int, char, then BOOLEN, etc. Non-primitive classes, arrays, avoid inter, you see, basis. Now next is, you see, hypertext markup language, HTML. HTML is a markup language used to create web pages. It defines the structure and presentation of content on the web. Key features are uses tags, that is, you see, to define elements. It uses tags to define elements. Support multimedia integration like images and videos. Enables hyperlinking to navigate between documents. Compatible with all browsers, ensuring universal accessibility. Next is Microsoft, you see, Excel. Excel is a powerful spreadsheet program that allows users to organize, analyze, and visualize data effectively. Then features of Microsoft Excel are cells, formulas and functions, graphing tools, formatting options, data security. So under cells, basic units of data entry found by intersecting rows and columns, formulas and functions, perform calculations and automate tasks, graphing tools, create bar charts, pie charts, and more for data visualization, formatting options, customize the appearance of data with fonts, colors, and alignment. Data security, protect workbooks with passwords to prevent, you see, unauthorized, you see, access. Now, in this unit, what we have studied, this unit provides a comprehensive, you see, introduction to programming languages, control structures, and tools like VBNet, Java, HTML, and Excel. It emphasizes the importance of programming in, you see, problem solving, and explores features that, you see, make each tool uniquely suited for specific tasks. Mastery of these concepts equips learners to develop efficient, secure, and versatile software applications. Now we come on block 4, support systems for management decisions. We are studying unit 12, database resource management. Now organizations today heavily rely on databases for their, you see, operations. Databases serve as, you see, essential tool in various domains. Educational institutions use them to maintain student records, libraries for tracking reading materials and providing indexing by subject, author or title, and banks for managing customer, you see, data. Employee information, transactions, and loans. Beyond these examples, production houses, warehouses, healthcare, and research and development sectors also employ databases to streamline their processes. So organizations today heavily rely on databases for their operations. You see, databases serve as essential tool in various domains. Educational institutions use them to maintain student records, libraries for tracking reading materials and providing indexing by subject, author or title, and banks for managing customer data, employee information, transactions, and loans. Beyond these examples, production houses, warehouses, healthcare, and research and development sectors also employ databases to streamline their processes. The integration of application software with the World Wide Web and internet technologies has made database management more essential. So this is all due to customer relationship management, you see. And then SCM, support chain management, often only require a customization, eliminating the need to develop new application software. Data as an organizational resource. Before the advent of computers, managing data was a cumbersome process. It was very boring work. Managing the data, involving physical documents and human processing. The limitations of manual operations included inefficiency and delays, often resulting in outdated information. Computers revolutionized this process, enabling faster and more accurate data handling. Data as an organizational resource. In today's information-driven age, the ability to acquire, manage, and process accurate and timely data is crucial for organizational success. Hardware advancements have driven the development of sophisticated software, allowing for efficient data management. Data versus information. Data, raw details such as those about factories, customers, competitors, or suppliers. It is collected for monitoring business activities and processes but holds no inherent meaning. By this, suppose sales, you're having the figure of all the past 5 years. You can compare, whether it is increasing or decreasing. If it is decreasing, why it is decreasing. Then information, meaningful and relevant facts derived from data used for decision making and taking action. Information refines data into a usable form tailored to the application at hand. Examples of information system include banking systems, online shopping platforms, ticket reservation systems. These systems transform raw data into actionable information, meeting the specific needs of you. For example, in a bank, if suppose you will give it the check at the counter for payment, that staff will post your check in the computer in your account, and cashier will give you the money. So the moment the officer posts that check in the ledger, it goes up to the balance sheet of the bank. Simultaneously, all the things are posted. When the public dealings are closed at 4 o'clock, so after that one can do day end and take out the balance sheet, take out the balance sheet of the bank as on that date. All those transactions will be included in this. Now next is information, meaningful and relevant facts derived from data used for decision making and taking action. Information refines data into a usable form tailored to the application at hand. Examples of information system include banking systems, online shopping platforms, and ticket reservation systems. These systems transforms raw data into actionable information, meeting the specific needs of users. Now, in our banking system, then online shopping also, then railway ticket, you just go, you write the train number and you write the station where you have to board the train and the station where you will leave the train. So by this, they feed this information in the system. Train number also, of course, you have to write name and train number and name of the train. So then they will issue to you the ticket so fast. Similarly, this banking system and ticket reservation, it has become, now they're doing it very fast with the help of computerization. These systems transfer raw data into actionable information, meeting the specific needs of users. Next is queries of effective data accuracy. Errors in data. Suppose, for example, you have to post 72, instead of 72, you have posted 27. Suppose you have to post 163, instead of 163, you have posted 136. Now, in such cases where you have, in place of 36 you wrote 63. Such type of mistakes you have done. So this is if the difference which you get is divisible by 9, then this sort of mistake is there. So accuracy errors in data, regardless of how thoroughly analyzed, lead to poor decision making. While achieving perfect accuracy is costly and time intensive, effort should be made to minimize errors. Timeliness, data must be available when needed. Delays in data availability render it less useful or irrelevant. For example, outdated electoral rolls can disrupt election processes. Relevance, data must be pertinent to the organization's goals and decision making needs. Despite advances in technology, relevant data can hinder effective decision making. Next is organizing data. The method of data organization have evolved significantly, transitioning from manual to automated systems. Then historical context, manual data processing. Initially, organizations relied on clerks and physical tools such as forms, leather books, and adding machines. This approach was slow and results were often not updated. Mechanized systems, early systems like the Holrith tabulation system utilize punched cards for data recording and processing. This mechanization improved efficiency but had limitations. Next is key terms in organization. One is bit. The smallest unit of data in a computer representing a binary value, 0 or 1. Bits are grouped into larger units for practical application. Byte, a collection of 8 bits used to represent characters, that is letters, numbers, symbols. Bytes form the building blocks of data storage. Then field, a specific data element within a record such as phone number in a customer database. Fields represent individual attributes of an entity and are organized into columns in database tables. So key terms in data organization, we have studied about bit, byte, and field. Then record, a collection of fields grouped to represent a specific entity such as a customer's complete contact information. In databases, records form the rows of a table. Database, an organized collection of data, easily accessible, manageable, and updatable. Databases may store various types of content, including text, numbers, images, audio, and video. Now, entities, attributes, and key fields in databases. Entity, a person, place, or object about which data is collected, that is a customer. Attribute, a characteristic of an entity such as customer's address or salary. Key field, a unique identifier for a record such as a customer ID. Key fields enable efficient data retrieval and management. File organization in databases, files in a DVMS can be organized in the sequential, index, sequential, random, direct. So sequential records are stored in a specific order suitable for batch processing. Index, sequential, combine sequential storage with an index for faster access. Random, direct, allows direct access to records using a key field, ensuring quick data retrieval. Next is DBMS and its components. A database management system, DBMS, is essential for organizations to efficiently manage their data and ensure accurate decision making. DBMS allows organizations to combine data from different sources, minimizing redundancy, duplicate data, and providing secure access. With DBMS, users can create, store, assess, modify, and monitor data. Some commonly used DBMS tool include Oracle, SQL, then server, then again SQL, and Microsoft, SS. Now, DBMS and its components. One of the key advantage of DBMS is that it allows users to retrieve data without needing to know how it is stored. This is similar to ordering food in a restaurant. The customer simply chooses from a menu without needing to understand how the food is prepared or stored. So DBMS takes care of retrieving and delivering the required data to the user. Now, components of DBMS. DBMS is made up of various software components that work together to manage databases efficiently. Each component has a specific role in handling and processing action. These components are explained in the next slide. So DBMS is made up of various software components that work together to manage databases efficiently. Each component has a specific role in handling and processing data. These components are explained in database below. The DML precompiler is responsible for processing data manipulation language DML. How we write data manipulation language DML statements. These are commands used to insert, update, delete, or retrieve data from the database. The precompiler converts DML statements written in application programs into standard procedure calls in the host programming language. It interacts with the query processor to generate appropriate code for execution. Alternate name is DML processor or processor. The DDL compiler processes data definition language. DDL means data definition language. Data definition language DDL statements, which are used to define the database structure, that is creating tables, databases, or relationships. Next is it translates DDL commands into metadata tables that store information about the database structure. These tables are utilized by other components of DBMS to perform their functions. Next is file manager. The file manager is responsible for managing the storage structure and space of files on the physical disk. It locates the block of data in the disk containing the required record. The file manager interacts with the disk manager to retrieve the book or page containing the requested data. Once retrieved, it provides the record to the data manager for further processing. So the file manager is responsible for managing the storage structure and space of files on the physical disk. It locates the block of data on the disk containing the required record. The file manager interacts with the disk manager to retrieve the block or page containing the requested data. Once retrieved, it provides the record to the data manager for further processing. Next is disk manager. The disk manager handles all the physical input-output of operations related to storage. It is part of the operating system and provides the specific block or page requested by the file manager. The disk manager ensures smooth communication between the DBMS and the hardware. Data manager. Now the data manager, database manager. Same thing, it is data manager, database manager. The data manager, also known as the database control system, acts as the intermediary between stored data and user queries. Next is the data manager ensures that data is stored, retrieved, and manipulated efficiently while maintaining data integrity and security. Now, data manager, what are the responsibilities? He converts user queries into commands that the file system can execute. He ensures the integrity of the data by enforcing constraints, that is, prevents invalid data entity, that is, an employee's joining data cannot be earlier than the current date. Next is secures the database by restricting access to unauthorized users. Next is query processor. The query processor manages user queries written in data manipulation language and converts them into a format that can be understood and executed by the data manager. Now functions. It processes user requests for retrieving, updating, or deleting data. It ensures that queries are optimized for efficient execution. Next is data dictionary. Features of the data dictionary. It includes descriptions of the database, tables, attributes, and relationships. It contains information about database users and their permissions, programs and tables used by specific users, relationships between tables and fields. Features of the data dictionary helps the database administrator DBA in designing, maintaining, and troubleshooting the database. It supports its end users and managers by aiding in project planning and execution. So it supports end users and managers by aiding in project planning and execution. So features of data dictionary are: it helps the data administrator DBA, we call database administrator DBA, in designing, maintaining, and troubleshooting the database. It supports end users and managers by aiding in project planning and execution. Now, data dictionary, what is the benefits? Similar to an index in a book, the data dictionary simplifies the process of finding records or information in a database, improves efficiency in database operations by offering a clear structure and quick access to metadata. So, what are the benefits? Similar to an index in a book, the data dictionary simplifies the process of finding records or information in a database. It improves efficiency in database operations by offering a clear structure and quick access to metadata. Now, complexity and cost. The complexity of the data dictionary increases with additional features, which in turn raises its cost. Despite the cost, it plays a crucial role in ensuring smooth database operations. Data modeling. Organizations, rely on databases to store and process data, generating valuable information for decision making. Data modeling refers to the process of creating a blueprint for the database that visually represents the system's data and its relationships. This process is crucial for defining and analyzing data requirements to support business processes. A data model serves as a roadmap or blueprint, aiding developers, analysts, and stakeholders in understanding how data will be structured and utilized within a system. It ensures that business rules and requirements are captured accurately and integrated into the system's design. Purpose of data modeling. Data modeling provides a systematic approach to structuring data in a standard, consistent, and predictable manner. This ensures effective data management and communication among stakeholders. It includes defining the types of data used, highlighting relationships between data types, illustrating how data can be grouped, formatted, and organized, supporting business processes by creating efficient databases. Attributes and tables. In the entity relationship, model entities and relationships are represented as tables within a database. Each table contains columns referred to as attributes that store specific types of data. For instance, in a database storing employee details, attributes like name, address, phone, and age might be included. Each attribute corresponds to a particular type of data. Name would typically be a character type, while age and phone would be numeric types. Attributes often derive their values from a defined set called a domain, which specifies the permissible values for a particular attribute. For example, the domain of an attribute like age might be restricted to integers between 18 and 25 for certain applications, such as job eligibility, because normally at this age only you see students apply for pass outs, they apply for jobs. Similarly, a marks attribute could be constrained to values between 0 and 10. You see, normally exam is of 100 marks. So marks will be from within 0 to 100, allowing only one decimal place. Domains ensure data consistency, enabling accurate validation and meaningful comparisons. Developments in database technology. A database management system (DBMS) consists of a structured collection of data and software that enables users to manage and assess it. Relationship database management system (RDBMS) organize data in tables, each with unique names containing fields, columns, and records rows. Additionally, data warehouses have emerged as advanced repositories where data from multiple sources is unified under a single scheme. Development in database technology. Recent advancements in database technology have enabled the handling of complex data types. Special data like maps and geographic coordinates can now be managed alongside engineering design data such as blueprints for buildings or circuit layouts. Multimedia data, including images, audio, and video files, can also be stored and retrieved efficiently. Furthermore, time-sensitive data such as historical records and stock exchange information is supported, making databases indispensable for applications acquiring time-based analysis. Database administration and their role. The maintenance of large and complex databases overseen by a database administrator, DBA we call it. The database administrator holds the highest level of expertise in database management and is responsible for supervising, controlling, and administering the database. A DBA manages user permissions, ensuring that unauthorized individuals cannot access the database by granting and revoking permissions as needed. The database administrator protects sensitive data. Database administrator and their role. The DBA's role extends to resolving conflicts when multiple users attempt to access shared resources, always prioritizing the organization's benefit. They are also responsible for maintaining the accuracy of the data, ensuring only valid information is stored in the database. Other responsibilities include updating the database to accommodate organizational growth, ensuring efficient performance, and receiving data in case of failures due to human errors, hardware malfunctions, or natural disasters. Database and data warehousing. A database is a structured collection of data focused on a specific subject. A data warehouse, first conceptualized by Bill Inman in 1990, goes beyond the traditional database by serving as a centralized repository of data collected from various sources. According to Inman, a data warehouse is subject-oriented, integrated, time-variant, and non-volatile, supporting decision-making processes. Database and data warehousing. A data warehouse integrates data from the multiple organizational functions such as sales, marketing, HR, finance, and production, ensuring a unified view of analysis. Data within a warehouse is standardized to maintain uniformity and is typically updated periodically, enabling time-based computations. Unlike operational databases, data warehouses are non-volatile, meaning data is rarely deleted or modified. So this was our last slide. So in this slide, what we have studied, we have studied about database administrators and their role in the maintenance of large and complex databases is overseen by database administrator. The database administrator holds the highest level of expertise in database management and is responsible for supervising, controlling and administering the database. A DBA manages user permissions, ensuring that unauthorized individuals cannot access the database. By granting and revoking permissions as needed, the database administrator protects sensitive data. The DBA's role extends to resolving conflicts when multiple users attempt to access shared resources, always prioritizing the organization's benefit. They are also responsible for maintaining the accuracy of the data, ensuring only valid information is stored in the database. Other responsibilities include updating the database to accommodate organizational growth, ensuring efficient performance, and recovering data in case of failures due to human errors, hardware malfunctions, or natural disasters. A database is a structured collection of data focused on a specific subject. A data warehouse first conceptualized by Bill Inman in 1990 goes beyond the traditional database by serving as a centralized repository of data collected from various sources. According to Inman, a data warehouse is subject-oriented, integrated, time-variant, and non-volatile, supporting decision-making processes. A data warehouse integrates, data from multiple organizational functions such as sales, whether the sale is, daily sales in the year, in which month the sales were more, in which month the sale was, less. Marketing, then human resource, then finance, bank, if suppose bank account is there, current account, bank account, looking after bank account, then other, finance related matters, and production, ensuring a unified view for analysis. Production, whether it is how to increase it, and the sales of the last 3-4 years will tell you whether it is increasing or decreasing. Okay, students, we are closing this session. Thank you very much, students. Thank you very much.